Okay, all right. Good morning, all. We will start our and resume our journey of new and innovative product development called Ipro. Okay, so today we are so the sessions are divided into different categories, right? So we are at Ipro 105 today, and there is a tagline for every session, right? The wave of technology evolution. You will see always when I present it. That's a theme of that particular session, right? And if you remember, uh, we had a gap of one class, and yeah, I take that blame on me. So this is the journey, right? We all are supposed to traverse right from the market to the product, and you can't jump, as I always say, from market to product directly. If you do it, you can. If you're lucky, you will succeed, but most likely you will fall in the valley. So there is a systematic structured method. If we follow it, most likely we are going to go to arrive at a very good, attractive, profitable, innovative product. That's what we are talking about. We talked about markets, insights, MPVs, ideas, right? Trees and FAD tools and all those tools, Medici tool. Then we talked about product function as a basis which connects both the worlds. The left is the customer world and the right is the technology or engineering world, right? We talked about product functions and things like that, and then we moved into the technology. And before we come out of technology, we talked about technology selection, right? And let me cover a few slides, and I want to delve a little bit deeper into technology today, because uh, this is the area which is uh, it's a sort of a white space. It is not being taught anywhere in the academics, neither in industry. It's a very niche area. So I will take an opportunity to take you through some part of it in terms of the technology strategy, technology road mapping, technology forecasting, and things like that. What generally, I mean, it's more of a flavor of how it is done, and some part of it on the patents. The some small overview on the patent. Okay, so the key concept we visited is the functions, technology, right? We IFR, ideal final result, product architecture, technology selections. We talked about it last time. This diagram is the master function diagram. I don't want you to forget this anytime in your entire career of engineering, right? So product every product in the under the sun is meant to deliver some function, and the function is transfer or transformation of mass, energy, information of flow element. We call it as emit as an acronym, and ultimately we separate the working element. We keep it separate because that comes from the customer. Like, we said clean clothes, sorry, clothes are the working element for washing machine, and ultimately what customer is interested is in this new state of the working element. That is the interest. The solution and the product are just main means of doing it, and they are not the ideal solution. No product today is the ideal. It will keep evolving towards ideal final result. Then we also said when the product is performing the function, the functionality is measured using some measures, right? If you are hitting the water, the temperature of the water is a measure, and there are desired measures and desired performance, and there are some undesired performance also, which comes along in terms of corrosion, in terms of noise and vibrations and emissions and everything, wastage of water, all that is undesired. So this is the element of this function diagram. Each of these, whatever is written, is very important. And working element, flow elements are can be same, but we must separate the working element and treat it separately, because that is ultimately the customer focus. And then we write a function statement in terms of emit, which is energy, mass, information transfer. Objective, why are we doing it, right? And then objective should have the working element mentioned into this, right? So as an example, we convert the electrical energy into the swirling or whirling motion or kinetic energy of the water to clean the clothes, right? So objective is also mentioned in the statement. So we talked about this diagram of refrigeration problem in the rural area, right? Where there is a dependency on the grid power, and you also want the temperature to be as low as possible. So IFR will definitely lie in near the origin where you have zero dependency. It's an ideal solution, right? So no barriers, and you will have absolute zero or very low average storage temperature. You start with something which is your baseline, where you are not really cooling or doing anything, and then you populate all the ideas which is generated on this MPV plot, including simple idea to the biggest idea. And we are interested in the solution which is close to the vector. This is called as innovation vector, which connects the baseline to the IFR. Anywhere else, if you go away, it is you are not actually you are moving away and away from this vector. It may look a very good solution in isolation, but it doesn't really help the customer. So this is an important criteria, right? MPV plot is an important criteria. And then this is the solution we saw, Chotu Cool, which is completely new technology in the refrigeration. It is works on the DC power, 12-volt battery, and uses the solid state refrigeration technology, right? It's a function which is changing, and that's why it's a technology change. You can use the battery, you can charge it for whenever the power is there, and rest of the time it will work. And if you look at this plot, it may not really cool down to this level. It is somewhere in between, which is enough for the market which you are serving. Okay. You can also use renewable to charge this battery. All that can be done, but the core of the technology is the thermoelectric or solid state cooling system. As I said, this is a direct application of FAD tool, feature adoption tool, because this technology is not developed by the people from this company or Godrej. This is borrowed from space industry, which is already using it. They already have established it. So it is just about adapting it, right? What can you adapt from industry, nature, and society? That is a direct application of this tool. We have already seen this tool. Okay. So this is the technology selection, because see, once we select the technology, then rest of the things should follow. You can design it, you can dimension it, you can use this color, you can choose the material of the plastic, you can put some ventilation holes, you can put a handle, you can put a stand, you can do validation, verification, you can do stress calculation, all that you can do, and that is going to take around 70% of your time. But if you to choose the wrong technology, then all what you do is not going to help you. Okay, not going to help you. So technology selection is important, and this is again coming back to the same plot. When you populate the ideas, they will automatically get clustered together, and they will be distinguished from each other by the theme of technology. So color represents the technology here. When the technology changes, the performance changes. They will lie on a different coordinate on this plot. They cannot lie on the same place. At least a third dimension will be different in terms of the sizing, cost, weight. So you can also add the third dimension here in terms of the size of these balloons. So this is MPV plot. This line we said is a trade-off line. Anything which we do on this line is not an innovation. So this brown color is not an innovation, although it may look very good. You are able to achieve this MPV level to better than your optimum point. So somebody may get impressed with this work, but we should not be. And all the effort should move along this vector. Even if you move inch on this vector, is a great step to take. Okay. So that is what we said. It's a more of a recap. So I want to spend more time on the technology. Okay, more time on the technology today, and then we will move into the design this tomorrow or maybe next week. So we would extend this Ipro for one more week. There is some more things I think I should cover. So please make sure you attend it and we cover really the end-to-end topics. Okay, now this is an exercise, right? It doesn't stop whenever we interact, and that always helps me to learn from you, and it keeps the session very live. So, we are talking about a simple thing called wheel. Okay. Now wheel, when I say wheel, whatever you see on the screen, you can say tire and whatever you come, it's all part of the wheel system. So can you list down all the technologies and innovations you know about automotive wheel? Right? Old, new, future, whatever you know, just list it down and share it in the chat. And I'm going to explain you after that a very elegant tool about technology themes, right? So yeah, your turn. What are all the technologies and innovations you know? Alloys wheels, Cipram Sim. Yeah, yeah, yeah. So go on. No boundaries here. Self-driving car, self-driving car segments, rubber tire acts as primary suspension. Good, good, good. Radial and tubeless tires. Yeah, yeah. Alloy wheel, 12 shape changing wheels. Wow. Shape changing wheels according to road structure. Very good. Lightweight wheel, tubeless. Yeah, yeah. Very good. Tubeless. Okay, tell me more. Everything, whatever is going in this area. Auto parking, very good. Airless. EV, okay. Foldable wheels. No boundaries, guys. Don't worry about it. Design of steel rim, blast proof, or disc brake, self cooling. Anti puncture, self balancing, vertical extended valve, rotating seats, advanced locks, run flat, flyer, piezoelectric sensor in the wheel. Wow. Valvorine, autonomous robo puncture resistance, and okay. Dynamic balancing, ABS, ABS. Wow. I I forgot about it. Thanks for reminding me. The dynamic balancing. Yeah, I agree. Brake power generation. Anything else? Airless wheel. Okay. If you want to take another 10 seconds, I am okay. ABS and EBD, regenerative braking. All right. Okay. Now let me introduce you to a very simple but very powerful tool called Enigma. Okay, you will not see it on Google for all the right reasons. So this is a tool called Enigma. Now Enigma means it's a small acronym for energy, information, materials, and geometry. Okay. So all the technologies, whatever you listed down, or whatever is there in the literature, patents, and on the road, they can be categorized into four themes. And this is not only for wheel. Any technology you take in the under the sun for any product, it always will fall in either of the four. Either it's about energy fields, I'll talk about it, or it could be material change, it could be geometry or configuration, and it could be about information. Okay, it's a very high level abstract themes. These are all technology themes, and out of these, the energy field, uh, whatever is dominated by energy, we call it as a core technologies. Or I mean, again, I'm bringing some terminology. So whatever is dominated by energy is a core, and whatever is dominated by other three are called child technologies. That's a terminology. So parent and the child. Somebody also call it as a primary or core and the secondary. All that can happen, but ultimately, whatever you spoke, Adaptive wheel, spherical wheel, this is all geometry. Somebody talked about sensors and control, it is about information. Somebody talk about regenerative braking, where you are converting the energy back into the electricity, it is all about energy. Somebody would have talked about some materials, advanced materials and things like that for the wheel and the tire. Alloy, somebody said alloy, that is material. If you are talking about the tool, that is again a geometry. Somebody says airless. Now airless means what? You need to tell me. Is it a change in the energy? Is it a change in the geometry? Is it a change in information? So this is our specifics, specifics to the technology theme. What exactly are you controlling? What exactly are you changing? That is what generally the technology themes are defined as. Okay, take an example. Yeah, so energy, as I said, energy. I am, uh, or I would say in this diagram, the energy box is inflated, right? Because that is the primary that defines the primary technology, the mother technology of the product, and then comes the child. Let's take our example of energy. See, look at these energy fields. Like take an example of energy like water heater. Then we will go into the details. Water heater, it performs the action on the water. Water is your working element. You want to heat it. Now, source of energy itself, we are talking about the energy. Keep it simple, right? Source of the energy itself changes the technology of the heater, right? Now, what are the source of the energy for heating the water, right? And as I said, when the energy changes, technology changes because function is changing. Function is all about emit energy, mass, information transfer and transformation. Can you tell me? I mean, I can pick up very simple. Make electric. I know when you change the electric, you get the electric heater. Okay. When you use the solar power, you get electromagnetics because solar is a electromagnetic wave. Things like that. Can you just list down all the technologies which comes to your mind, right from the gravity to nuclear? And gravity again, please note, gravity is listed down here is an energy. Gravity is a source of energy. It's a potential energy you can probably use if you want. So can you list down technologies and list down technologies in specific? And let me tell you, these technologies may not be there in the market today. It may be there, it may not be there, it may come in the future. So don't worry about whether you have seen it or not, but tell me how will you do that if I tell you to what comes to your mind? So somebody says atomic fusion, right? So nuclear is, of course, you will use it. Now somebody may say, how can I use nuclear in my home? Don't worry about it. We are not getting into the practical part of it, right? Design is all about practical and safety and things like this. Is just talking about what are all possibilities in the technology area. Hydroelectric power generation, gravity. Very good, Venkat. Hydroelectric power generation, gravity. Okay. Solar powered, what else? Chemical, yeah, exothermic reaction inside a steel container. Right. So LPG, somebody may also, I have seen that there are LPG water heaters. It's a technology change. Piston cylinder arrangement, hydraulics, yes. Hot spring powered heater, yes. Geothermal, yeah. What comes to your mind? Electromagnetic motors, yeah, you can use that also for heating the water. Yes, I agree. Okay, anything else? Biogas, yeah, biogas is again chemical energy converted into heat energy, right? Anything else? Nobody talked about mechanical. Are there any mechanical ways of heating the water? If you do not have, if you do not have LPG and electric, what will you do? Ethanol, yeah, ethanol, it's chemical. You can use ethanol, petrol, diesel. Compressor heat exchanger, yes. Compressor heat exchanger, very good. Yeah, I mean, see, you can have a compressor. You can have anything. You can have mechanical. See, you can also You can have if you do not have anything like electricity or thermal, you can have like a bicycle which can pump the compressor. It will heat it will reject the heat, and that heat will hit the water. All that can be done. So what I'm saying is, when the source of the energy is changing, the technology changes. Simple. You cannot have say yeah, you cannot have a heater which is working on the chemical, and suddenly next day you want to use nuclear. That is not possible. You need to change the technology. Okay, thank you. I will skip this slide. So you already answered it. Now this is little bit deeper in the waste heat from power plant. Hari says, excellent. See, look at this. Now we talked about energy in that four 2 by 2 matrix. So energy has these four sub elements in that energy, right? One is new energy source itself, the way we did it now: solar heater, nuclear energy, battery electric vehicle, right? The source of energy is changing and the technology will change. Then comes hybridization of energy sources, which is hybrid vehicles. Example, these are all examples. Microgrids, dual fuel, right? Two source of energy. You can have the hybrid electric water heater also, which can run on electric as well as solar as well as LPG. You can design that. You can have that technology. Then energy flow management, right? So last chat, if you see waste heat from Hari Krishnan, recover energy loss. You see that last point. So this is theme. These are all themes. Okay. Under energy, these are sub bullets, you can say. Energy flow management has control energy flow, storage of energy, recover energy loss, and active field control. Active field controls means we control the energy field, like electric field, right? You can when electric field is same as energy field. Active suspension, active tire pressure management, automatic climate control in your, that is called as active field control. Now, don't worry too much about this. This is an involved topic in itself, but these are the technology themes. If you're if you are not, if you list down your ideas and you are not getting any ideas in this bucket energy flow, then probably your ideation is missing. Something is, something is not complete. So that's the time you can go back and just see if I can do something. It's a verification tool. Okay, this is not an ideation tool, but it's a verification of technology themes, and this is applicable almost to all products. As I said, input or output energy field defines the primary or core technology. So energy is the mother. Then comes the child or secondary. Okay, you may want to treat it child or secondary, but doesn't matter actually. But if you change the material, the technology changes. Like composites, like composite materials, carbon fibers, advanced alloys. Then you have, by the way, guys, I have some background noise here. Uh, Not from my home, but from outside. Please bear with it. Composites, then, right? Composite materials, carbon fibers, advanced alloys, advanced properties of the material. So this is all under material. Please note that. Note that high strength, high flexibility, lower weight. And these are just examples. Okay, external additives like fuel additives, surface coatings, property boosters. Then smart material, smart fluids, piezoelectric injectors, active carbon. Smart materials is they are the materials which changes their properties on the fly, right? As per the boundary conditions or operating conditions. So that's a material. Third, I talked about geometry. Geometry is again new configuration or layout, right? Rear engine vehicle, Tata Nano. It's not a change. If you see this example will help you. It's not a change in the primary technology of automobile. It is not like automotive technology is changing. If you ask me, Nano, is it a technology change? Not to the level of, like a mother technology change, but yeah, there is an innovation, there is change in the geometry. So somebody can also, people also call it as child technology. So rear engine vehicle, series and shunt motors. This is more of, configuration changing. You are playing with the elements for getting some benefits. Front end loader and backhoe excavators, right? Then you have geometry features like simple fins, baffle plate, bumps, notches. We know that. Dynamic geometry control, right? We control the geometry itself, like area, like variable valve timing, right? Which we are changing the valve timing itself. Variable geometry control, right? We can keep changing the blade angles of the fan and things like that. That's a geometry control. Adapt to solar panel movement, right? Solar panel can keep moving facing the sun. That's all dynamic geometry. Then shapes and convolutions. So you can have like different complex shapes like variable stiffness springs, aerodynamic blade profile, and porous geometries and things like that, right? And each of these is patentable. If you can come out with a very different shape, which is different from NACA profile, but it is going. Somebody says it's slide 11 on our screen. What is the slide, guys? You are seeing geometry architecture, right? Can somebody confirm? Sorry, there is no slide number here. Can somebody confirm if you are seeing the green boxes and title as geometry architecture? Yeah,
Yes, sir.
60.
Yes, sir.
Okay, thank you. Okay, then it makes sense. Thank you, guys. Okay, so this is geometry. So we talked about energy, we talked about material, ENIGMA. Remember that acronym. Talked about geometry. Now fourth is information. Somebody already said it, multiple sensors and trying wheel with the sensors and things like that. Sensors for diagnostics, example sensors for dynamic optimization, sensors for active function, right? That is multiple sensors and feedback. Connected systems, Internet of Things, infotainment, connected cars. This is all under the bucket of information. Data analytics, big data analytics, users, smart apps, machine learning under data analytics. It is all under information, right? Intelligent interface like digital twin, autopilot, artificial intelligence, all that falls under intelligent interface. All right. So this is what the summary of this tool is. Okay. If you apply this tool and or if you list down all the portfolios of you, the idea for the product which you are working, you will see that it all falls under this only. It can't go beyond this. Or if it goes beyond, I would like to know. And then probably I will pass on this feedback to our trees masters. Okay. Okay. So this is, please remember, ENIGMA is a simple acronym for energy, information, geometry, and materials. Now look at the wheel. We started with reinventing the wheel, right? All what you said appears here. They are all under the four themes. Twill, somebody said about shape changing wheel. It is already there, developed by DARPA, which is a defense wing of in US, and it changes the shape. It's the same wheel. On the left, it is circular. Now it is triangular. Depending upon the terrain, they change it. Shock absorbing wheel, right? Energy, regenerative braking, four wheel drive, ATPC. Do you know anybody know the ATPC? This is active field control. This is a direct application of active field control. Anybody can guess what is ATPC? You must have heard somewhere. No? Okay. ATPC is automatic tire pressure control. Automatic tire pressure control. So it's again active field control. You can control the tire pressure on the go. Active tire pressure control. Yeah, thanks Mugeshwar. Mugesh Kanan. This is active field control, right? Super elastic shape memory alloy. This is also material. Wheel with Internet of Things. Nothing new. This is a direct image from a company called Continental. They are already working on called wheel with IoT, so that it can tell you the wear pattern. It can give you an SMS if you have to change your wear. It can tell you if your tire pressures are deflating beyond the point or reducing beyond the point, and it will also tell you if your tire pressure is over the limit. It creates a safety issue. All that warnings and everything will be done. This is a Continental patent again. IoT. Wheel with sustainable material. This is part of research, adaptive treats and things like that. Okay, treats are also adaptive. Geometry, the way I see it, dynamic geometry control. So you can also control not just the entire wheel shape, but even some feature, local feature can be controlled dynamically, right? So you can control treats patterns as well. Okay, now this is again, this is a wheel technology, by the way. Shift in the core. Now see, this is all with energy source coming from the engine and the transmission, right? Mechanical energy source. The energy source is not changing here. If you look at all this, energy source is same. These are all child technologies, if you ask me. But if the energy source itself has moved from mechanical to, this is magnetic. Now this is based, now this is a concept car. Okay, I have not seen this car. If somebody has seen it, they are I will be very happy. But this is a car which is and this is not something which is very academic or hypothetical. We already have this maglev trains running in Japan, which runs not on the wheels but on the magnetic energy source. Yeah, magnetic levitation, somebody is already saying. So this is change in the energy field, right, to the magnetic. And it is still, now technology has changed. You don't see wheel there. You will not see the wheel, but it's a wheel, invisible wheel, which performs the meets the purpose of taking this vehicle ahead. Okay, so this is the shift in the core technology. The energy source itself is changing, right? So car with magnetic levitation effect, invisible or no wheels, right? This is how technology keeps changing. And then again, once this changes, then it takes its own path and time to evolve in the area of material. Then you have information, geometry, small incremental changes you will keep doing for next 20 years. And then again, it will change to some other field. And that's how disruptions keeps happening. So this is what a summary of what I just said. So that is where we get the technology S curves. So when you have first S curve, which is based on the primary technology, then after a point, you look at this S curve, okay? Follow my laser. After a point, this gets flattened up. You cannot increase the ideality. You know the definition of ideality, by the way. You can't change, you can improve the performance beyond a point. It will get flattened and flattened and flattened. Nothing much can be done. It's saturated with that technology. Then you have to jump on the next curve, and that we call it as a radical innovation. Somebody may call it as a disruptive innovations, and all that terminologies are there. But ultimately, this happens, and then again you keep improving on that S curves, and then again you jump, and again you jump, and this all moves towards ideal final result. You will never reach IFR. It's a direction. True north, if you remember. This is a north direction. Keep moving towards north. You will never reach something called north. It's a direction. Okay. Okay. So this is how the technology. Prashant said like electric vehicle in today's world. Yeah, yeah, excellent. So we are completely moving from IC engine to electric. Change in the source. It's a disruption. You need a different skill, different technology, different supply chain, different understanding. Everything changes. In between, there is an hybrid. So you can always say there is a S curve on hybrid, and then there is another S curve on fully electric, and then so on. All right. Yeah, hydrogen fuel vehicles. You know this now. You can very well go back and connect. From now, we are talking about vehicles, right? Which is as big as the complete system. And this is where I'm going to spend a little bit more, 2 or 5 minutes more. Okay. Now we talked about hydrogen fuel vehicles, right? Somebody is saying hydrogen, somebody says electric vehicle. Now we talked about vehicle. We are talking about vehicle is a system, but in the vehicle is made up of components like energy source, engine. In this case, it is diesel, petrol, whatever, or CNG. Then you have transmission, you have energy sink, you have working unit, you have active control. Everything is there. Now tell me this technology S curves. It is applicable to which elements? Or the are you getting the point? Technology S curve is applicable to which elements for the vehicle? Energy source. Okay. Any other question? Energy, architectural element. No, you have the six elements here, guys. Don't go anywhere. You have the six elements. I'm keeping it very simple. Somebody says all. Somebody says transmission. Transmission. Okay. Any other questions? Technology S curves, right? Where technology is supposed to evolve, then move to the next and move to the next and move to the next. Is it applicable to which elements? Working unit, engine, the active control, all, all. Okay. Thank you. Okay. Be very clear. If each one of these is a function. Each one of these is a technology. Each one of these element, even a small nut and bolt in your car or vehicle or in your washing machine or vacuum cleaner, is a technology element. You may not see it a technology, but it's a function. It's performing some function, and as I said, function is a technology. So if it is talking about technology S curves, it is applicable to all the elements. If they are performing the functions, it is applicable to all the elements, even including nut and bolt. Your nut and bolt also supposed to evolve. Okay, everything supposed to evolve. So please take a note. It is applicable to all. Okay. Now there is one more element or dimension to that, which I want you to take a note of it. So before going there, this is your exercise. If you want to take it back, right, and use this, just generate the ideas on the battery, right? Battery is supposed to evolve, right? You know what battery is doing to working element is motor here. Very simple. This is not new, and it is supposed to evolve along this ideality plot, or you can even say MPV plot. You can alternatively use ideality or MPV. It will ultimately they will converge. By the way, this is an exercise for you, right? List down all the battery technology and see under this Enigma tool and see if you can draw this kind of technology S curves, this kind of curves where you have seen first generation, then second and third, and can you just draw it as a function of time? Okay, and to realize what is really happening, you can draw this MPV. What exactly they are trying to solve? What exactly is the trade-off uh, through which the ideality is improving, right? Unless we resolve the trade-off, ideality cannot improve. We know it. Okay. By the way, before just out of to make this little bit more interactive, interesting, can somebody tell me what is the trade-off or key core conflict for battery MPV1 versus MPV2? What versus what? Can somebody tell me? Then it is easier once you know the trade-off, like power versus fuel efficiency. We talked about it, right? Torque versus transmission size and things like that. Size versus power density versus energy density. Thank you, Nilesh. I will not now take more time, right? So it's a power density versus energy density. That's a key conflict in the battery. Power density versus all other are secondary. You can always have those as secondary child trade-offs. The primary trade-off is power density versus energy density. So please see if you can put this on the map. See all the battery, explore, research out investigate, analyze them, check it, read about them, and see if you can put an S curves as a part of your exercise. Okay. Okay, thank you. Now let's move to, we talked about now all the elements, right? We said technology is applicable to all the elements, but in reality, or as a matter of evolutionary trend, uh, evolution does not happen at the same rate for everything. Okay, component would evolve faster, and as you move towards super system, subsystem, system, and super system, they will evolve slower and slower and slower. Okay, for example, if you see your the injection system in the vehicle has evolved quite a lot. The turbocharger has evolved quite a lot. The chassis has, or braking system, I would say, has evolved quite a lot. Suspension has evolved quite a lot. But vehicle has not really evolved to that extent. Vehicle still remains like a vehicle. It's not like a disruption in the vehicle. So it has taken that time of 30 years or 40 years, right? So it is going to take the time when it comes to, because the inertia goes up. We still talk about moving on the road, right? We are not really even thinking of moving in the air for domestic travel or within the city travel. It's far-fetched idea. We are still talking about, we still talk about car. Although the technologies have evolved drastically at a component level, and then gradually the speed will drop down as you move towards component to subsystem to system to super system. Okay, so this is generally the speed of evolution is. You will not see directly, direct jump from IC engine to hydrogen in 2 years, and hydrogen to magnetic effect in another 2 years. No, it is going to take its own time. Other components is going to evolve. That's how it happens. Whether we like it or not, that's how it is. Now, when I say that's how it is, it's not again my opinion, right? I'm coming from the body of a systematic innovation research where people have observed it, not only for automobile, but for across the products, across the industries, including pharmaceuticals and textiles and food. And they came out with a pattern, right? Oh, this is something which is common. This is something which is happening. This is something, it's like a law of the land. You are not, no technology is, defying this law. So let us make it a part of a structure and be aware about it. Be aware. All right. Now, as I said, patterns, right? So people are observing how the things are moving across industries. There is a research, and this is what this is very unique way, unique research where lot of technologies are studied across industries, across the domains, including from nut and bolt to the as big as the airship, sorry, your space shuttle, and then they come, and then this, and what has really happened out of that, they've the people have found out the patterns that yeah, something, it's not completely random. There is a structure to technology evolution. There is a, as if there are laws. And interestingly, Alschuler and the systematic innovation team has came out with the laws of technology evolution, as if there is a laws of motion described by Newton, right? So they came out with the laws of technology evolution. This is how the technology evolves. And there is a question here: can we predict the technology evolution? Yes, the answer is yes. People are saying yes, we can, because we have a historical data across industries, and we have put down some principles, some trends, and so let's talk about it today. Okay, let's talk about it today. And again, I will not get into too much of detail today, uh, because this is again a topic. This is like advanced modules when you learn about something called technology strategy, technology planning, technology road mapping. All that is covers into this area. Okay, now, so I'm always keeping it simple. the way I do it every time. I always want to make the thing simple. See, technology evolves under common rules. That as I said. Look at this knife. This knife is evolved form. This is the latest evolved form. Look at this. This has a curvature. Look at the solar panel. This is again a latest picture. Look at that. This is a curvature. Both of these things were flat in the beginning. They were flat. Now they are curved. Both of them actually have moved as simple as knife. Nothing to do with solar, right? They now now how it happened, forget about it. But this is what actually has happened. This is what actually happens as technology evolves. People ultimately land up in creating the same thing, whether they know these laws or not. Now, idea for us is to know these laws proactively and use them, apply them systematically. That is where we get the power of dictating or driving and understanding, and no surprises. So they are both are following the same law. And what is that law? I will come to that. But both of them are following the same direction. The geometry is changing. The geometry from flat is changing to something like a curve, and it has its own benefit, by the way. The knife has its own benefit when you keep it curve as against it is flat. It helps you to cut it better in terms of your manual efforts and things. You know it better, or you can ask somebody who is a kitchen expert. And solar panel again has its own benefit when you keep it curve. It is going to capture the more sunlight for the same footprint. Now this innovation comes under geometry part, Enigma tool. Yeah. Now we are talking about the time axis. Now Enigma has a space. You can say in the space today, I can say now we are putting a time axis. How the things are, this is not going to stop here, guys. This is going to move on and on and on. You will see in future a serrated knife, a knife which has a very convoluted shape. I mean, just don't get complacent with this. Solar panel in future may not look like this. It may have a very completely different shape in the area of geometry. It's not going to. This is not the end of it. So let me talk about now this trends and laws. Okay. So if you look at, this is the radar plot of, on the previous slide we just talked about one element, and which is this element. If you are you able to see my laser? Can you somebody confirm? Because this is little bit cluttered slide. Are you able to see my laser? No. No, I'm seeing a laser. Yeah, I'm pointing out the laser, guys. Oh, you are not seeing
No,
the
sir.
laser.
No, sir. The laser is not visible.
Very strange. What about now? Hmm. Do you see my arrow? Yeah, I'm not able to understand this. Last time I am all the time using laser, by the way. I am drawing a line. Do you see the line at least now? Somebody says I could see slide number 20. No, I am on slide 27. Do you see the red pane? No.
No, sir.
Very strange. I don't know why is it happening, because I have a clear laser pointed option here. Anyway, doesn't matter. Fine. I will point out. We will not stop. That's all right. Okay. Uh, we'll fix this issue. I don't know why is it happening. Is there any other option here? Just give me a minute. Hmm. No, this is the only option. Anyway, okay, don't worry. So this is a radar. You can unshare and share again. No, this is not about sharing. I don't think. Okay, I'll stop and I have to upload this presentation, but I don't think it's a presentation issue. Okay, don't worry, guys. Don't worry. That doesn't matter. By the way, do you see this geometry evolution of volumetric? Sorry, geometry evolution of linear construction on the right side of this radar plot. Right side and the bottom. Geometry evolution of linear construction. Read it and you will see that. Yeah, you are able to see that. Geometry evolution of linear construction. Okay. So this is the trend for the solar panel and that knife. Geometry evolution of linear construction. It was a linear earlier, flat, linear. Now it is evolved and it is no longer linear. It has become non-linear. So it says the linearity of the non-linearity in the geometry will increase along this line. That's how this is how the technology evolution will happen along this axis, right? So it will evolve along the axis, along this axis, and so all other point. I don't have we don't have bandwidth today to cover all of it. We may have a different session altogether. I mean, this may need another 2 or 3 weeks explaining each and everything. But I'm giving you a flavor that all of it we need to study. What does it mean? Okay, it needs some practice. It's not that you see, look at it, and you know it next day. It needs some practice. What does it mean by see, macro to nanoscale? What does it mean by? It says you may switch off video. Can I do that and see what? Now, do you see the screen? Do you see the laser? Do you see the laser? No, so I forget. That's okay. Don't worry. It's not a laser dependent presentation. That's all okay. Everything is there on the screen. Okay. All right. Okay. Now some more interesting examples, right? Some more interesting examples. Can you spot out the trend? Old TV to smart TV, right? Uh, Old TV to smart TV. Spring to pneumatic suspension to active suspension. Conventional tire to tires with sensors, measurable wear, temperature. Yeah, you can wear temperature tire and all that. Carburetor to multi-port fuel injection to gasoline direct injection. And this is a common trend. Okay, there is a common trend. That's what people said. Look at the industry. All industries are different from each other. They don't talk to each other, but they are all evolved. This is an evolution happened in a single direction. Ceiling fan to air cooler to air cooler. Single direction. What is the direction you can point out? Any guess? And it is there on the radar plot, but any guess? Cathode ray tool. Cathode ray has nothing to do with suspension. Tell me the abstract rule. What is happening? Gasoline direct carburetor, MPFI, gasoline direct injection, active suspension, manual to automatic, uncontrolled to controlled. Very good, very good, very good. Anything coming to improved design is always there. Improved improved design, please. Improved design is a very generic word. Evolution, yeah, that's what I'm saying. What is evolving? What is changing on the adaptive suspension? Adaptive suspension is only for suspension. Okay. Somebody said it. Can you pick up? Efficiency and usefulness improved. No, 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 no. That is all. See, you are seeing. You are seeing the effects. I'm saying something specific is changing along the way. User controlled. No, active suspension is not a user controlled thing. GDI is not a user controlled. But you are close. You are getting it. See, this is what people in the sense the people who work in this area of how the technology evolves. Technology changes, of course, guys. Technology, of course, is changing, but there is a dimension too. Technology can change. I have been going back or going forward, right? I'll give you. This is what exactly the trend is: increasing controllability and adaptability of the system. This is the trend. This is not again my words. These are the trends from the from this radar plot, which is technology evolution trends. So there is increasing controllability somewhere here. Uh, if you can point out, it will be here. Yeah, controllability is here. If you see on the top, top left, top top left side on the little bit on the little bit on the top on the left side, controllability. So this is the trend is. Okay, this is the trend, increasing controllability and adaptability of the system. And look at it is applicable to all the systems irrespective of the industry. And it see arrow means it is not that it is just one step and we are done. It is going to evolve and evolve and evolve in future. Okay, see like carburetor. Like, see carburetor, there is no control on the combustion. Simple. I'll give and take an example of carburetor. Then it goes to multi-port fuel injection, little bit better control because at least now you are injecting and deciding the timing of that injection, but injection still happens in the port. Now we want to take further more control on the combustion, so you are directly injecting into the combustion chamber. And similarly on the tires, no control. Now it could be right. There is no. We are improving the controllability. There is no control on what is happening to the tire pressure, wear. You are at the mercy of road conditions. You don't know really. Today even I don't know when I drive what is happening to my tire. Is it safe? Not safe? So this trend is saying that the in controllability on the system will improve. The you in the sense the system will become more and more controllable when it operates and delivers its function. So ultimately it will adapt, right? It will change. It will give you warnings so that there is a proactive control. It will have machine learning so that it learns and do and take a better decisions. Systems are now evolving towards taking the decisions, increasing controllability. Automatically you can make out the trend. Look at our air conditioner, right? Now they are talking about intelligent air conditioner. It will adapt to the environment. You don't have to set the temperature. It will decide what temperature it should set. It will decide the airflow patterns. It will take care itself, right? It will take care. It will have a better and better controllability. And just extrapolate it, and you will see what is really happening. TV, I can't explain it. TV is becoming more smart, more decision taking, more decision, more controllable. You did not have you did not have any control. Look at the old TV. No control on colors. It was black and white. Now you have a better control on colors. You can change brightness. You can change contrast. You can change resolution. You can change 2D to 3D. What you can change it. You have all the controls on your TVs. You can change the voice resolution. You can change the bass and the treble and whatnot. Everything can be controlled in the smart TV and the future. That's how the TVs are evolving. Okay. Okay. Just one quick question. If you apply the trend of geometry evolution to TV, what do you get? Geometry evolution to TV, what do you get? No, geometry evolution. to the smart TV, which is on the curve. Yeah, curved TV, curved screens, exactly. Curved TV, curved screen. Wallpaper TV. Yeah, yeah. So wallpaper TV, I don't know, but if you look at the, say, I'm reading, going by the trend, not my imagination. Trend says geometry will evolve from linear to non-linear, the way solar panel is doing. Same thing is likely to happen, and see if it makes sense, right? That's the direction it is pointing. It doesn't mean that it has to be done, because there are other enablers which has to come together. One direction alone will just, it's direction, but ultimately we need to take care of all the enablers. Okay, so flat, yeah, so curved screen. Do you see a curved screen somewhere? Foldable screen, I agree, Prashant. Foldable screen, exactly. Do you see the curved screen TV somewhere? Is it there, or it is just an academic or hypothetical idea? Any guess? It's there. Raj Gauri said, yeah, it's there. Thank you. It's there. Curved screen is there. Samsung. By the way, Samsung has it. Samsung uses systematic innovation as a part of their strategy. So I was never surprised if Samsung comes out with a curved TV. Samsung, all the innovations in the Samsung is spurred by the systematic innovation methods. Okay, and it is mandatory for Samsung R&D engineer to get trained and get a certified engineer in this area, because one of my friend is working in there. Okay, now somebody may say, but it doesn't make sense, it is a flop TV. That is all fine. The market and the customer may not like. You already said it. The technology is not a sure shot uh, bullet for giving you a profitable product. We are only talking about technology, not the profit, because profit comes from the customer and insights. If they don't need it, don't give them. Okay, they may not need it, please do not give them. But if they need it, if it is a delighter, if you remember our first diagram, first class, cano diagram, if it is delighter, if it is going to make your product attractive, go and do it. Now this is another spot the trend. This is again, there is even a curved screen desktop. Yeah, I agree. Increasing geometry, degrees of freedom of the system, right? This is another trend. Sorry, I think I should have stayed. Just read that. Normal vehicle body to aerodynamic. Geometry is changing, right? No, we don't use the flat vehicle body. Even the trucks and the bullet trains are changing shape to the aerodynamic. Disc brakes with fins. Like geometry, some geometry changes. Mexican heart combustion bowl to re-entrant. Little bit of more complex combustion. Flat solar, curved solar. Following the same trend. Now this is another trend. Dot matrix printer to laser printer, right? Wired network to wireless communication. Can you can you spot the trend? Wheeled train to maglev. Maglev means magnetic levitation. Geared and to hydraulic. Energy source. Any guess? Any guess? Advancements. Of course, it is an advancement. We are talking about what actually changed. Reduced human intervention. Could be correct. Also, wired network to wireless. I don't know. Nothing to do with human intervention. Uh, System. Okay, making it more efficient. No, see, when you say advanced, efficient, effective, we are talking about that is of course how you made it. What did you do? So technology trends about how part of it. Okay, so I'll give you the answer. increasing field substitution. So somebody says field means energy field. So somebody said it energy. We are changing the field from. So this is called as a field substitution. So there is a wire. Now we are going wireless. It's a field. It's a electromagnetic field. Um, right. Hydraulic is a field. Right. Thermal is a field. Chemical is a field. So either energy source or energy field. So there is a term called energy field. Okay. Can you say gear transmission, hydraulic transmission? What can be the next version of this? If you want to move from, can you tell me anything related to transmission? What is after hydraulic? Is there any other field you can think about? Pneumatic, very good. Pneumatic transmission, yes. Energy, magnetic transmission, very good. Yes. What else? There is one more transmission. We are very close. Vacuum, nahi rahe. They're very close. You are very close. Pneumatic transmission, I agree. Electromagnetic transmission, quite possible. Very much possible. Just see, increasing field substitution. You need to keep changing the fields, right? Keep changing the fields from hydraulic to magnetic to electric to electromagnetic, right? So you said electromagnetic, I'll say electric transmission. Somebody, I don't know, nobody has said it, but electric transmission is there. Electric motors today, nothing but electric transmission, right? It's a transmission. Electric motor does not produce their power. They transmit the power from battery to the wheels. So that is electric transmission. It's a field. It's a field substitution. Okay. So the mechanical field is substituted by hydraulic, and hydraulic will be substituted by electric, and then electromagnetic is not far from that. All right. This is the beauty of the trends. Okay. So this is where I leave you for the trends. Now, something interesting and something important. Hyperloop, somebody says Ramon. Yeah, I agree. Hyperloop is again change in the technology itself. We are not talking about moving on the road, moving in the some conduit. So perfectly fine, perfectly okay. Hyperloop can be on that S curve on your automobile when you turn to automobile. Now this is another example, but I will skip it. This is another trend. Can you tell me? I mean, just again, two seconds. Pressure cooker regenerative braking. Nothing, no connection as such. But they are following the same trend. Earlier, people used to cook in the open container, right? No pressure cooker. Even solar water. There is some theme here. Can you point out? They evolved in the same direction. All right. Any guess? You would have never believed that pressure cooker and regenerative braking has anything to do with, but it is. They evolved in the same direction. Exactly, Prashant said it. Increasing use of resources. Prashant, very well. Thank you. Integration and use of resources from ecosystem. Okay. It is the trend. Again, this is the trend. It is like a law. So they even call it as a law of technology evolution. This is the law which every technology. I'm repeating because this is like a laws. We learn Newton's laws of motion, and then you can apply it. Everywhere. To the bullet car, to your two wheelers, to your anything which is moving. Newton's laws are applicable. There is no doubt. So you don't really then study different vehicles differently. You study using the same laws and you understand. In the same way, we call it as a laws, which which we need to of course learn, practice, and apply to whichever system you have, right? So regenerative braking is using the resources. So this braking energy is a resource available. You use it and convert it into electric or whatever energy. Pressure cooker, the steam which is going from this container is a resource available. It taps that resource to heat it even at altitudes. So it is tapping that resource to heat it. So and then heating happens faster also. Solar, of course, you are using the resource, and likewise resource available, which is renewable energy. Okay, so again, an exercise, you can just pick up any one of it and apply those trends. Okay, now this is one exercise which was done by one of the student who just passed out from did his masters, right? And he applied it out of fun, or I don't know why, what, and he applied it using the same laws for to an automobile, and he came out with this kind of S curves. This is not my. This is from a postgraduate student who even has not entered into the industry. Now, believe this person, when he enters into industry and R&D, he can understand, he can appreciate, and even drive a lot of things, right? So this is from a student coming from a post graduation studies, talking about current car, multi-fuel, advanced engine, advanced driving controls, multi-purpose, modular, advanced emissions, mild, hybrid. Now this may not be 100% accurate. That's all right. You can always improve it. But see, look at this: advanced engine and transmission controls, materials, VVT, variable valve, GDS, stop start, electronic CVT, and automatic manual transmission, automatic transmission. Then your battery. So now it has changed. Okay, change in the S curve: battery electric vehicle, fuel cell electric vehicle, then IoT, multi-energy vehicles, biofuel, solar, battery, gas, wind, safe, smart, autonomous vehicles, artificial intelligence powered, intelligent, all-terrain, super compact, flexible vehicles. And look at the last part: car as a companion with emotional quotient. So it is no longer car. This is your companion. So in the future we will not call it as a car but a companion, with whom you will be able to talk, share, because the car is going to have not only IQ but EQ as well, right? The car can sense the stress, anxiety, and can even make a decision for you. That's the future, and it all moves towards the IFR. IFR doesn't change. Okay, so this is from us. This is the power of these tools, and this is the tool people use it consciously to lay down the technology roadmap. So whenever you hear about technology planning, technology roadmap creation, technology strategy, and all that, it all comes from here. You can lay down what is the, and then there are other elements. We just talk about technology, but there are other elements like core strengths, SWOT analysis, right? What are the strengths of your organization? What are the strengths of your supplier, supply chain, and things like that? Looking at all that, what is the strength of the country in which you are operating, the policies and things like that. Looking at all that, a company, this is the key input to that exercise, and then company and technology organization can lay down the map next year and 5 years down the line, 10 years down the line, what I would do and where the company would like to invest. For example, General Motors have announced that they will stop manufacturing IC engines in 2025, if I'm not wrong. They will 100% move to electric vehicles. That's their technology roadmap. Okay, and things like that. By the way, I heard a company like Honda has 25 years of technology plan already available today. 25 years of map is already available. They know what what are their what they want to invest in and what they want to pursue. Now at this stage, right, we need to pause. We are not right. We talked about ideas, and we talked about functions and technologies and things like that. And this is the phase where we have to look back. We have ideas. We have selected the theme, right? Technology theme, like Chotu Cool refrigerator. You are clear that this is what I want to pursue. This is going to help my customers and resolve the contradictions, and everything is in place. But this is the time you need to pause and now file a IP, which is intellectual property or patent. This is the phase for any product development, and you need to now go back to the people who work in the IP area in your organization, or there are consultants outside, and present your ideas, because they, of course, they should be new, innovative, and file it. Even if the product is not there on the ground, even if it is not been validated, verified, your designer has not even seen it, that is all fine. It will follow. But at this stage, you need to go and take the patent for your idea, because if you don't, your competitors will make copy from you, and then whatever work you have done so far is just easily available for your competitor. Nobody will like it, at least business people will not like it. So this is the time for us, the technology community, to go and file the patent or IP. Now, why IP is important? Look at this trend, 1975 to 2020. All the organizations today, all the modern organization, they are real assets. So this is an intangible assets and tangible assets, right? So earlier the assets were land and equipments. Now the assets are IP. So look at 2020. Organizations, 90% assets organizations are intangible, which is IP, intangible, IP or patents. And only 10% is tangible, like your machines and land and all those things. Look at all business models. They don't own anything. They only own ideas. Lot of companies are only, their IP is only ideas. They don't own anything. They just engage other players like Ola, right? Ola and Uber. They have ideas. They don't buy the cars. The cars do not belong to them. They facilitate the network. They have the idea and they have all the IPs around it, right? So 90% of it is 90% is all about intangible, and it will keep polarizing like this in future. Okay, now let me spend a couple of minutes on IP and patents before we conclude today. Okay, so that it is for you, it is very clear what are we talking about. So when we say IP, we are talking about patent, because IP has a general bandwidth or spectrum. Like copyright is also IP, design and jewelry is also IP. So I'm not talking about that. Patent is one of the IP, and that is where that is what is more applicable to us. So what is patent? Is a legal title, okay, which grants the holder exclusive right. Please understand, to prevent others from making, using, or offering, or selling, importing a product that infringes his or her patent without his authorization. Okay, exclusive right. So somebody's, we also call it as a negative right. Negative right means I have a patent, so nobody else is supposed to develop that idea and develop the product based on that idea. But it does not mandate me to develop it. So I can keep sitting on that idea for 20 years. Generally, it is limited time up to 20 years if you look at. And even I will not allow others to do. So that's a negative right. And in the countries for which the patent was granted. So it is subjected to the country in which the patent is filed and uh, and um, and issued by the government of that country or patent office of that country, right? So if you have a patent in America only, or India only, and not in China, the somebody from China is able to copy it and do it, because you have not filed it in the country, in that country. So three things: exclusive right, country is important, and this is not forever. It is only for 20 years. After 20 years, it automatically is invalid. Everybody else can copy your idea. Now, another important, in return for this protection, the holder has to disclose the invention to the public. That is why the patent is always available to the public. So all the all the patents and patent applications are available to the public in the public domain. So Google patent is a site. There are many other sites. Just search it out. WIPO, WIPO is a site where you can learn about. You can read anybody's patent. Okay. So you have to reveal that invention disclosure. We call it as a reveal the disclosure, reveal what actually you are doing to the public, so that nobody copies it and you get the exclusive right. Okay. Now this is a patent. Now this is a criteria what can be patented. Not it's not that any idea can be patented. There is a criteria. So either it should be novel. First, the three criteria. It must be novel. Must be novel. Must be non-obvious. Okay, non-obvious. Inventive step. So there has to be inventive step. We will talk about it. I will explain all of this a little bit tomorrow. Non-obvious means inventive step to differentiate from prior art. So nobody should have done this before. It should be different from the prior art. Art should not be obvious and useful. Useful be for industry. It should not be harmful to the society, right? It should not be. I mean, if you are manufacturing some harmful weapons, then that's not doesn't fit into a patentability criteria. So these are the three main criteria. We will talk about it with some examples. And I also suggest you to go through a website called WIPO, which is World Intellectual Property Organization. They have the course on the patent basics, right? You can see patent basics, patent search, patent analytics course. So free of cost, very good course on the WIPO site. You can take, you can read about it. It's a topic in itself. People are charging lakhs of rupees in just talking on patents and training the people, but this is all free, at least the basics part of it, and I'm there to help you out. I have been trained on patents by many good trainers, right? So this is the time to go and file the patent. We'll just talk about one or two examples tomorrow, and then we will come back to the design. So we will be done with the technology and we will start with the design on this V-shape next time onwards. Okay, so that's why the next class will be more of go to the drawing board 106. Now this is the time we need to go to drawing board, get to the get to the design, the real design on the drawing board and make it work, right? So that's it for today, everyone. Let's catch up tomorrow and talk about little bit on patents tomorrow, little bit, not detailed, and then get into the design. All right, then thanks a lot again for your patience